The point P with coordinates pi over 2, 1 lies on the curve with the equation 4x sine x equals pi y squared plus 2x. I need to find the equation of the normal to the curve at P. So, normal, I want to differentiate to get my gradient function, and I want to substitute the coordinate in to get the gradient of the curve at that point. Then do the negative reciprocal for the normal. Then I'm going to do y equals mx plus c. So to differentiate this, I'm going to have to do this implicitly because I've got my y's and the x's all mixed up together. So I'm going to differentiate the right-hand side, the left-hand side with respect to x, and then I'll differentiate the right-hand side with respect to x. So on the left-hand side, I can see I've got a 4x times sine x. So I'm going to have to use the product rule to differentiate this. So let's let u be 4x and v be sine x. Differentiating the 4x, I get 4. Differentiating the sine x, I get cos x. Applying the product rule here then, I've got u dash times v plus v dash times u. So that's the left-hand side differentiated. Let's look at the right-hand side now. Now we've got two separate terms. We've got the pi y squared and we've got the 2x. So we can differentiate them separately. The pi y squared, now that's obviously a y function. So I'm going to differentiate that with respect to y and then multiply it by dy by dx. That's how we do implicit differentiation. So when I differentiate pi y squared with respect to y, I'd get 2 pi y. This is me differentiating this with respect to y. Now to make it so that it is with respect to x, I'm going to multiply this by dy by dx. Now differentiating the 2x, I get 2. Right, let me now get dy by dx, the gradient function. So I'm going to subtract the 2 from both sides. So that's going to give me the 2 pi y dy by dx. And then if I divide both sides by 2 pi y, that'll give me my gradient function. I'm now going to substitute the coordinate pi over 2 and 1 in. So I will get 4 sine pi over 2 plus 4 times pi over 2 cos pi over 2 minus 2 over 2 pi times 1. The sine pi over 2 is just 1. So actually, when I times that by the 4, I'll just get 4. The cos pi over 2 is 0. So when I times that by the 4 times pi over 2, all of that's going to be 0. So my numerator is just 4 minus 2, which is 2. So I get 2 over 2 pi, which is just going to simplify to be 1 over pi. So dy by dx is 1 over pi. That's the gradient of the curve at point P. So the gradient of the normal will be the negative reciprocal of that. So the negative reciprocal of 1 over pi is negative pi. So the gradient of my normal is minus pi. I can now do y equals mx plus c. And if I substitute my coordinate in, it's going to tell me what my y-intercept, my c, is going to be. So the y is 1, The x is pi over 2. So 1 equals minus pi squared over 2 plus c. If I add the pi squared over 2 to both sides, I find that that is my y-intercept, and therefore the equation of my normal is y equals minus pi x plus 1 plus pi squared over 2. And I'm probably going to leave my answer exactly like that. It doesn't say I have to write it in any other way, so I think that is perfectly fine for leaving my answer.